last talk of the day. I will try to be efficient as possible, but if it will be boring, there will be party like they announced, so you will get your beers and everything. And my name is Sinan, and I want to talk about how you can unlock your main thread and get rid of some of the ANRs and frozen frames in your application. But who am I to talk about it? I have like 12 years of experience. In the past, like 10 years ago, I actually was a part of a book, and I was responsible for like performance part. And I'm happy to be able to give this talk 10 years later, and I plan to do a small retro afterwards to compare, has anything changed in the last 10 years? Also, I work at Delivery Hero, and we deliver food over 70 countries. And if you ever use any of those brands, you probably use our application, and the driver and the rider or the person who delivered the food use the application that I'm working on. So basically, we are developing the logistic part of it, and people who are outside delivering the food in the rain, in the sun, in the mud, using our application. So performance and the smooth application, smooth running runtime is very important for them to have a much healthier work life. But what is our playground when we develop an application? We usually don't think about which thread we are in, because all of the methods look same, except the suspend functions. But when you have a class, when you have an Android application, the method you're calling doesn't immediately give which thread you're in. The reason is most of them is main thread, and the calculations you're doing will be run on the main thread itself, and we have limited resources to run. Even though Android is trying to update the main Android runtime, ART, over the air, with every baseline update, they try to make it efficient, we will always have this limited resource. And another important thing in how we develop our application, how we test, versus what the real user is actually experiencing in the wild. The reason is, there will be thousands of different applications, Android phones. There will be different environment, different internet connection situation, or places to use. In our case, people need to use their application while they're delivering the food. And it could be in front of any customer, underground, or maybe very high in the skyscraper. So we really don't know what kind of production issues they might have based on looking at what we can test. And this is one of the examples. I will try to go this one quick, but this is one of our riders trying to use application to get a new order. And this is the reality that we have to live. And that means our application needs to be snappy to be satisfy all of the riders that we have, all of the users that we have. It's not that you will end up something like that, but it's important to measure what your application has. And there are different stages of the junks. And the first is slow rendering. What is it? So Android, like any other device with the screen, it tries to refresh the frame as much as it can. And if you have a device with the 60 Hz, that means it will try to refresh every 16.3 seconds. And if you have a device that has faster screen, that time will be shorter. But the slow frame definition is when your application tries to render the next frame, but main thread is still working, so it doesn't know what will end up on the screen and literally drop the next screen. And anything between 16 milliseconds to 700 milliseconds considered as slow rendering. And you will notice this one on the animations, transitions, and the screws. But something worse than that is frozen frames. That happens after 700 milliseconds. You might notice this one while doing a navigation from one activity to another one. Or while your application is starting, your main activity, or like whatever class that you will like launch, started, but it doesn't show anything on the screen because there might be injections, there might be other logics running on. And if it takes more than 700 milliseconds, which I do know from our production data, there are some wild phones with very slow RAM, very slow hardware, and they can easily reach this point. But one of the worst is the application not responding. Why? That means your users won't be able to use the application at that moment of time. And if they actually want to use it, the operating system will ask them, do you want to wait for this slow, sluggish application, or do you want to close it? And if they decide to close it, you will end up losing all of the precious input from the user. They had to start over again, and it's a frustration. And is this slowness only causing user experience problem? Definitely not. There will be lots of crashes because of this slowness. Even though you design your application with the best architecture, even though you have everything planned, if your application is rendered slow, it will create opportunities for users to register new clicks on the screen for the previous state, or there will be crashes from the foreground services, because the foreground service has to start in 5 seconds and has to show a notification to the users saying that, hey, I have something working on in the background, but I want it visible for you. And this contract is very critical, because if it doesn't show a notification, operating system kills your application. And the thing is, if your main activity is busy, it's very likely that you will hit that 5 seconds barrier and your application will be killed with a random crash on the foreground service that everything looks very nice. Another thing about the ANRs, when you look at your reporting tools, you might see lots of different ANR stack traces. And sometimes you go there, it's a very simple parameter. It doesn't make any sense how you get an application not responding from that particular point. But it's usually not the point that stack trace is recorded, but it's the duration. So unfortunately, the default tools that we have in the Play Store or the Firebase doesn't provide any historical data about what happened, but there are other paid tools that provide this information and what your application is trying to do. And the reality is, when the operating system decides there's an ANR, it also tries to get a stack trace, but that stack trace also has a duration. It cannot take immediately, right? Because your application doesn't work at the moment and the system is trying to do something else. At that particular moment, you might miss the actual ANR. And that's why your reporting tools might not be able to show them to you. I wish there was a way to configure this one, for example, get a different stack trace from the first second or second second. But at the moment, we don't have that one. But the thing is, there are tools that you can configure your regression test application or development application to catch those slowness earlier. But how to measure it? Like I mentioned, your test users doesn't matter like that much, because they will have a controlled environment. When you develop yourself, you have debug variant, and it will be slow already. And we definitely need to be able to measure from the real data. What you can use, the Firebase Performance is free tool to use, and it gives slow rendering, frozen frame, and ANR out of box. It integrates with the activities, fragments, and a bunch of other cool features that you can use. But also there are other tools that you can consider if your company is willing to invest in more. There are more capable tools to use. Or if you like to build yourself, the library called Jenkstat is a new library that gives you more detailed information about what's happening on the screen, and what happened. Was it a junk, and how much frozen frame you had. So you can use this information to send this data to your own reporting system to create the dashboards that you want to have. So just look at which part of your application is much slower. But let's say you did all of them and you found a prioritized place of your application that you want to do profiling. So there are other tools like systrace, which gives lots of detailed information about what's happening in your thread, what the actual UI is trying to do, what the render thread is trying to do. And you can use those information to understand that if application is actually trying to do what you intend and coded in the first place. And it's very useful. For example, recycle view already has lots of systrace information in it. So when you have a scrolling issue and you look at the systrace, you see that when is the time that actually layout is created, when is the time this layout is actually drawn on the screen. And if there's any particular slowness, you can pinpoint which part of the code you need to fix rather than playing guess or trying to be an investigator. And this is how a bat looks like. So you can see there are like red elements on the screen. That means at that particular time, a couple of frames dropped. That means user saw the same thing. And there are some stuff going on the chart underneath. And I can, from this perspective, it doesn't give much. But this tool helps you to go deep dive in the threads and understand what's going on. Plus, you can add your own traces in your code to see what actually you intended to do in this particular situation. And this is also not a bad example. You can see the lines are yellow, but the good thing is There is nothing drop. The device struggled to understand what's going on the screen, but it was able to render under 60 milliseconds. So that means there was no junkiness. The device worked really hard, and you use all of the resources available, and everything is rendered. And user might not even see a slowness in this case if you are able to finish all of your frames, all of your operations under 60 milliseconds. Is there a magic solution for fixing the ANR? That will be really amazing, right? If we had an optimized application, just using a tool, a magical tool, and an output will be very fast. Thing is, there is no such a single thing, but we have responsibility to use available tools to make our applications optimized. And people always use and say that, hey, iOS applications are more optimized for their operating system. Yes, true, but we also, as an Android developer, has tools and ideas and years of learnings that we can use and apply to our applications to see. I will go over all of them, and my expectation is why I choose those, because they are the simplest one that I could think of as a low-hanging fruit. I expect I can inspire you to use at least one of those and see the results. Well, let's see how it will go. The first thing is using the multi-threads. Nowadays, coroutine is a famous one. We still have RxJava, but the idea is simple. When you have something that takes a lot of time on the main thread, we would like to offload that to a different one. If it is an IO operation, we might have a different IO queue. If it is a calculation, we might have a different queue. But the idea is always the same. Don't do anything that takes more than a couple of milliseconds on the main thread, and always try to offload and be reactive about what's going to happen. And the one good example could be, one good way to do it is making sure all of your code is main safe. And by doing so, you might need to think about your lowest level of your architecture and make sure that when you read something from the database, when you read something from the I/O, and you reach a file, always use the correct thread information and switch them as low as possible. So when you write high-level business logic, you don't need to care about which threads you are in. You don't need to care about, do I need to be on the UI thread? When you call your use cases, when you call it from your view models or the UI itself, it should be safe and fairly cheap to do this operation. We shouldn't let people to decide what they need to do, because in reality, that happened with lots of applications that I work with, that the repository didn't set anything, it was unopinionated, and when people use it, they forgot it, and we end up having long operation and long calculations or parsings happening on the main thread, and we only figured that those kind of things when we did spend our precious time doing profiling. Well, we mentioned that we would like to offload all of those information, all of those works to the different place, where there are, like I mentioned, solutions like RxJava, coroutine, but all of them uses something called pooling. And they would like to create a pool of threads, and they aim to reuse as much as possible. Some of those thread pools are bounded to your CPU count, and some of them are unbounded for I/O operations, because in the thread pools like I/O operations, your thread might wait something from the resources of the devices to understand, wait that resource to continue to job. But that means someone else can use a similar resource at the same time. And I list some of the frameworks, libraries that you might have in your application. And the good, interesting thing, if you use the basic constructors like empty one, the easy to use, get started document, all of them create their own thread pools. So when you start introducing lots of other libraries and don't configure them properly, you might end up having a bunch of thread pools that are responsible for creating a couple of threads at the beginning of your application, at the beginning of your transition. And thing is, creating those threads are expensive. Storing them in memory is even more expensive. It takes like 1 to 3 megabytes, and that affects the base memory usage of your application. And what you can do immediately, you can start sharing the RxJava, OKHTTP, coil, and the coroutine thread pools together in your application. And when we did this one, we reduced our thread count in a certain situation, like in the refresh case, from 180 to 130, and that immediately created a lower memory usage for our application, which means there will be more space for the features when they would like to allocate something, when they want to work on something. There will be less likely to garbage collection. Plus, another tool that you can use, which has magical effect, is R8 or the ProGuard. Those tools usually promoted as obfuscation, but they have other capabilities like optimization and the shrinking. What shrinking does is, if you have any unused code, it eliminates that. And what it will help, your application startup time will be faster because your DEX file will be smaller and there will be less operation on the runtime to decide that if this code is reachable or not. Plus, it doesn't need to be compiled ahead of time, or it doesn't need to be compiled just in time when your application runs in the wild. Also, these optimizations are really cool. And if you like to read more about it, there are really nice explanation on the official documentation. And Jake Wharton also did really good deep down on the individual optimization rules. But the idea is, for example, one of them is enum optimization, which replaces actual enum usage with the integer and the string. If you use the enum.getName, it really passes the string, and just because it already knows that name is a kind of static constant, it also inlines all of those names, the places where you are using it. So if you don't have any reflection using an application, like even if you have, those optimization will help a lot. And in the case of the Android, they claim that you might get 30%. And this is really important because Compose also itself really relies on those optimizations. When they develop something, while they're developing, if they know R8 can optimize this one during the compilation, they don't invest too much time on doing micro-optimization to the source code. They just say, hey, I will use this particular arithmetic operation or this class, but it will be optimized later on. And in the same way, you need to optimize your allocations as well. Like I mentioned in the thread pool example, we would like to have bare minimum memory usage as much as possible. So when other features would like to do animations, they would like to inflate new views, or like you want to do a caching operation or parsing operation, there needs to be some space. And if you don't have some space, there needs to be some juggling in the memory and clean it up. And if you don't, you might end up having some pictures like this. This is a very long view of a memory, but one thing that's happening is something is allocating, and the garbage collector tries to clean it. Something is allocating, and the garbage collectors try to allocate. And if you look at the blue part, that's the Java part, and it keeps increasing. So that means there are some references that our application, and the garbage collector is not able to clean because our application still holds the reference. And that means memory leak. So when you have a memory leak in your application, that increases the memory usage over time, and eventually it will end up in a situation that garbage collector will run a lot. And every time garbage collector runs, there will be probably not happening anymore in the recent version of the Android operating system, but there's always a chance that it can pause the main thread to do the operations, to do the cleanups that can give more space to your application. But how you can end up like a memory leak? If you have a reference to an object with a lifecycle, activity, context, view, or drivable, in a much bigger scope, in a much bigger lifecycle object, that means whenever those activities or views destroyed, you will still have the exact instance as a destroyed state. And if you do, if your users will be able to do this for multiple times, you end up having unnecessary memory usage in the device, and that will give the slow rendering over time, and eventually ANR possibly. And if they didn't kill your application until that time, you probably might end up having out-of-memory exceptions. And no matter what you do, no matter what you say, like do the other optimization, if you don't clean up your memories, the memory leaks, there will be always problem over time. And in our case, our writers average use 8 hours, our application. Our sister application, the customer application, is able to use 5 minutes or 7 minutes or something like that. So the session difference is huge. So we end up having those leaks problems or out of memory problems more than them. We had to fix them. So what you need to do for detection, you can definitely use leak canary. It gives information about those leaks early on while you're developing. The Android Studio also have reference watch. When you take a memory dump, it gives you information if there is any leaked activity or fragment or view, and it also lets you see which other class is holding that reference. Strict mode has very limited information about this one, but it also tells you that there are multiple main activities in the memory, and when you see those logs, that means it's time for you to investigate and what happened in the past that leads that particular part. And one other good thing that is not being promoted by Leak Canary, there's a sub-dependency, sub-architecture, like an artifact, called Plumper. So there are some known memory leaks in the operating system, on the Samsung phones, on the Huawei phones, on other phones, or directly in the operating system, or directly in the Android X. And this library has a list of known memory leaks, and with the reflection, or with other tricks, it tries to avoid them. For example, if a clipboard manager from an OEM device holds a reference when you first call it, or when someone else first call it, to the activity, because they only get context. This library, very opinionated, checks that if this class is there, and tries to initialize it with the application. So even if someone uses it, the first instance of the context that is initialized will be application, so there won't be any memory link. And it's really nice, and if you have out-of-memory issues, I highly suggest. Most of the tricks are for old operating systems, but it's always nice to get as much as you can. And the other topic that you think that you are helping us, the dependency injection, there are lots of discussion about which tools to use, but in reality, almost all of them are injecting your dependencies in the main thread. That means when you create a new class, when you do a navigation, everything happens on the main thread. And if there are expensive operations like encryptions, IO reads, or network, probably you cannot do the network operation, but initializing the OKHTTP will cause you lots of important milliseconds that could easily accumulate to have a slow rendering or frozen frame or eventually ANR. And in our recent release, we start doing OKHTTP initialization in the background, and we figured out that by profiling, there were 4 different encrypted shared preferences instances used by 4 different teams in the company, in the application. So what we did, discussed all of them, decided that we can benefit by using single encryption, and turned out that initialization of the encryption shared class was taking at 300 milliseconds. That means we spent unnecessary 900 milliseconds for the other features. Now, since we save it, our numbers are going down, and we already start seeing some results. And there are more optimization, like small optimizations like this that you can have. And the other idea is being able to inject almost all of your dependencies as lazy as possible by using Dagger Lazy or Dagger Java Inject Provider. What it does, it gives you a wrapper that doesn't immediately create the instance, but knows how to create it. So when you actually execute your logic, if you're already able to change the thread, and you can go IO thread or competition thread, when you call that lazy get or provider get, those objects will be initialized in that particular thread. And that already saves you the initialization cost. And if you like to prevent anyone to mistakenly inject your objects in the main thread, you can check the loopers, and if it's the main looper, you can prevent them while developing. And this is a nice trick that already helped us while injecting the OKHTTP in the wrong places, because any OKHTTP injection could take up 100 milliseconds, and maybe more if there are encryption things happening based on your signature. Well, what else you can do? There are resource optimizations. Any PNG or any file that you show on the screen comes from the IO. If you use WebP, which is more optimized and more efficient, the IO operations will be faster. Your initial application load up time will be faster. And Android Studio can already convert your PNGs to WebP. Plus, your application size will be smaller, your users will benefit from it. And the other one, which promoted a lot, is vector drawables. Vector drawables are nice. You can have single file rather than 5 or 6 different resolutions of the same PNG. It's scalable, but the trick is, the simple is better. For example, this guy is doing lots of heavy lifting there, but you don't even see it, because there's a couple of lines. And the thing is, device needs to do restoration of this image before even being able to render on the screen. That means it needs to understand which lines are there. But if you look at the, if you look at the behind of the scene, I can guarantee that's not metrics, and it goes like thousands of lines, because our designers think that it's a cool design and we can use it. But in the end, it ends up being like half a megabyte resource that takes a couple of 100 milliseconds on certain devices to load, because CPU needs to do calculation for every curve and every line. And you might think that, hey, we are using Compose, it must be optimized, but there are compositions happening, so all the UI system could be better, right? Then I would say probably no, because what we can do is being sure that we render the correct stuff. We would like to show the correct stuff on the screen. We can develop for correctness, because the Compose runtime, Compose compiler, and everything tries to make it more efficient as much as possible. But even if you have good code, by looking at it, you cannot understand it, because a class can be inline. A function can be inline, and inline functions cannot be skipped while doing recomposition, like box, layout, columns. You probably use them a lot, but they always inline what you write in them, and they literally runs on your own methods. That means there won't be any skipping for those. And also the mutability. By just looking at the class type, you don't understand that if it is mutable or not. You literally need to ask the compiler, hey, have you decided this one as a mutable or not? But something good, like Compose has something good, which is a donut hole skipping idea. That means there are lambdas and scopes, and every function is a scope, and every lambda is a scope. And Compose runtime understands that when we have a lambda, so basically a function is also kind of lambda that gets parameter, it knows which parameters are there and keep tracks of it. And if any of those changes, it tries to re-evaluate that lambda. But the good part is, they keep track of what's happening. And if you have smaller scope in your functions that gets values outside, that kind of gives you a special power. Why? Because Compose have different stages of rendering, the drawing, layout, placing. So if you use your lambdas like that, you might not end up a better API design. In this case, hey, it's possible to change the volume, but the API doesn't let you to do a smooth transition, and you might need to read. And it's exactly the same. So there are APIs on Compose which gets DPs. And the design of it suggests that you know how many DP you would like to put as offset, and it's being called one time. But also there is an alternative function of offset that gets lambda. But that lambda requires an integer, not a DP or not a dimension. And this is important because if you like to do an animation, you don't want to recompose the whole function itself, but you just like to change the position or offset of the class as much as you can without redrawing. And in this case, the offset lambda and the Compose runtime knows that it's a lambda and only use x and I. And when those values changes, the only offset lambda change. And if you look at the inside of the offset, it's used in the layout stage. That means everything is skipped until where that lambda is being used. So just be careful which functions that you are using, and if you already start doing while you are writing, if you already start doing lots of multiplication or start using density, trying to convert DPs to pixels, always think about, hey, is there a better version that use lambda of this API? In any case, even if you don't do any of those optimization, Play Store tries to do best as much as they can and creates profile based on your application. When your application started, it tries to understand when is the time the user start interacting with the application. It's very early of your main activity or like first activity on resume. And the reality is runtime will try to do compilation just in time, compilation to make sure the application will be much faster when runtime tries to compile. And those just-in-time compilations are being used. But it's also will be really nice if our application can do those compilations while we are installing. So for that one, there's something called cloud profiles. It's been announced like years ago. And if you call the report fully drawn, when the moment your application is actually interactable by the user, Play Store will track this one and create a profile that can be shareable over the Play Store to the other users. That means some of your users will end up having worse startup time, but the rest of them will benefit of the previous ones. So if you can start using the fully reported drone today, your upcoming updates will already start getting benefits. But the thing is, it takes hours or days to reach other users, and certain different devices could end up having certain different profiles. If we like to have control, we need to create a baseline profile. And what it does, it tells the Play Store and runtime saying that I need this class at the application startup time. So and the runtime will do ahead of time compilation to optimize all of the classes. So while your application is starting, and after every update, it will have a faster thing. We were thinking that, hey, we don't need baseline profiles, but last year we did have 54 releases, excluding the Christmas time and everything. So that means almost every week, someone has to update our application, and they will end up having at least one slow startup time, and that accumulates for the ANR and the frozen frames. So if you like to have pristine metrics that doesn't have any surprises, you can also use the baseline profiles to increase your application startup time. Plus, my other suggestion is measure as much as you can. There are tools like Firebase Performance, and before doing any optimization, it's always good to do the measurement first and verify it, because otherwise, there are really good ideas that you can get from a blog post, but you never know if it's going to work. And it's also applicable for any of the suggestions I make today. We're trying to do A/B tests for almost all of them as much as possible. We're using different brands to test it. We're doing testing frameworks to being able to test like thread pool size, vice versa. But in the end, the goal is reducing the resource usage as much as possible and being sure about it. You can start collecting the high-level metrics at first and understand which activity has the problem, which fragment has the problem, and from there, add more granular as possible, and then collect it. Yeah, I'd mentioned lots of things about how you can improve the main thread, but it's not the only side of the improvement. So we can pump everything back into the background thread, but the reality will be your application might be still slow. And a couple of examples that one, while doing the profiling, when we are not even looking at it, we found one of the HTTP interceptor was doing an unnecessary operation for 10 to 30 milliseconds for every network operation. So we went there, it tries to read a value from a file, and we checked that that value doesn't change over time, and we created in-memory cache and immediately start gaining those metrics. When you review the code, there's nothing wrong about it. It gets multiple approves. The unit test is there, integration test is there, and by just looking at it, you don't even understand that is there any problem or not. And while doing the profiling and measuring, we were able to save those milliseconds that accumulate a lot over time, the application. And I hope you will all have this kind of charts for your upcoming releases if you use any of the optimizations. If you don't see any chart like this for recent releases, we start investigating, hey, which of our experiment failed or which of the optimization we tried to do failed. But this is really nice moment that you can get validation from production. And this was for our application time to interact time, which was like 12 seconds, and it's reducing second by second with every release. Well, like I mentioned, I did write a chapter in a Turkish book. It might be sold out or maybe outdated, I don't know. But I would like to do some comparison. Back in the time, we had the view system. We had fancy devices. It was Android 2.3 and the 4.0 area. And we had other problems. We had to write a book. And we had to have a chapter about the performance. Thing wasn't pristine at the time. And we are, as a developer, sometimes don't know which function that we are calling is safe to call on the main thread, or sometimes doesn't know which function or mathematical operation or any other operation is fast. In that case, if you look at now, Now we have compose, we have dependency injection, we have those thread pools, all fancy tools that we can add our application. But that means I solved some of the problems that we had in the past, but created something new. And I would like to look at that, what I suggested like 10 years ago. The view hierarchy was a big problem, and the suggestion was using view stop. And if you ever worked in an old application that had lots of features, you can imagine the main activity tree has all of the features in there, and they probably set invisible or gone. But that means while doing the initialization, we had to do that layout file creation. We had to do IO read. But in the compose, with the basic if checks, that means we can just decide there needs to be an operation or not based on this if check. The other one, we had the list view, and the suggestion was using the view folder. Luckily, after a couple of years later, we got the recycle view, and now we have lazy column. And there are, you can see lots of comparison for the lazy column versus recycle view. Recycle view is very, very optimized, but it took 7 years to come there. So probably in the future, by enough time, we will be able to use the lazy column with the similar performance of the recycle view. Because the problem they're solving is different. Recycle view is introduced to get rid of all of the custom setups for the view folders and have a fast and smooth list view implementation that we can have. Lazy column is there for us to have easier development without thinking about, will there be a view folder when my function is called or when the layout is created. And this simply making the usages making usages simpler, they have opportunity to optimize later on. For the view, recycle view, we still need to do some optimization ourselves. In the past, every layout on the screen, even if they are invisible, they had to have layout operation and a draw operation. And some of those things were very, very slow, because if you need to draw a PNG that is big on the draw section, that might take some time. We had the tool showing that all the tree of the layout, showing that which one is very slow for the layouting, which one is very slow for the draw. Thanks, today we have donut skipping, so that means even if you have a big tree, only the values that you're updating will be updated in the downstream, and the rest of the things will not have to recompose themselves or draw themselves. Plus, memory leaks. The leak canary was new, fancy tool, and we still have it. There are ideas in the HILT, for example, they try to prevent while doing these memory leaks during the injection. For example, HILT doesn't let you inject an activity inside the view model scope, or it doesn't allow you to inject a view model into the application scope, because that means if you hold the reference, there will be leak. But that doesn't stop anyone to create a static field and hold it. So we still have problems, and that's a still valid one. And running in the background, in the book, I suggested creating the thread pools yourself or using the ASIC task. Luckily, we have much more professional and tested solution nowadays. And the thing is, we need to create our applications optimized as much as possible, and that's our responsibility. We cannot expect from a magical compiler to do our work. And as a developer, I think we have responsibility to check behind the get started document, because there could be in the recycle view option, for example, or in the core written example, or in the room database, live database, all of them create a thread pools. But not looking at the source code or not looking at the documentation, we might skip that as an advanced application developer, what we need to set up to have this optimized applications. And I really thank you for listening here, and I hope to see you all in the party later. Yeah.